This is a very interesting problem, number 43 on the physics problem set for scientists and engineers. This involves a system in which you are given a particle that is 5 kilograms with a defined force of 2x plus 4 newtons, and it's going from 1 meter to 5 meters. So, for part A, it's asking, what is this actual work that's going on here? Well, we can use our actual work definition, in which that actual work is really from your starting point to the ending point in one-dimensional space, of course, of the dot product of your force vector times the distance vector. Using that, we can say that's actually going to be from 1 meters to 5 meters. With our limits of integration are 1 meters to 5 meters of 2x plus 4, since you're given that definition. And that ends up being, from here, you have x squared plus 4x using calculus. Then using part 2 of the fundamental theorem, you end up with 40 joules. Now for part B, this is just another way of using concepts. It's asking, what is this change in potential energy from the system? Well, what it's asking is, as this is going from 1 meters to 5 meters, if our particle goes from here, it's saying, what is this change in potential energy as it's moving to this 4-meter displacement? Well, can't you see that as this thing is going to be moving through, it's going to be, if it would be at any point, there would be the kinetic energy plus this potential energy. Well, what you can then say is this change in, because since this work is going in the opposite direction of where you would have to be to gain your full potential energy, you can say this change in potential energy is actually going to be equal to your negative work, which, as we solved in A, is 40 joules. And as you can see, it makes sense because as you're bringing this in the opposite direction, you can say that it's lost a total of negative 40 joules to go up to here, because at this point it had a potential energy of 40 joules if you looked at this as a way where it originally didn't have any kinetic energy going on. But as you can see, as this worked through at this point, it lost all that potential energy, therefore it must be negative. So it is negative 40 joules. Now for C, if the kinetic energy of the particle has, at x is equal to 5 meters, if the speed is 3 meters per second at x is equal to 1. So we know that the speed is going to be equal to 3 meters per second. And how that's useful is, well, what is going to be useful to be able to do this problem is if you also realize another definition for work. That's equal to the change in kinetic energy, which is helpful because in order to actually solve this, what it's asking for is KE final, right? Well, of course, if you realize something, delta KE, what you have to realize is when this particle is here, it's that kinetic energy at here minus the kinetic energy here. Well, it says it's 3 meters per second at x is equal to 1 here. So we can actually say, because of our equation, we can say that this change in kinetic energy, right, that's going to be equal to our final kinetic energy, right, minus the original kinetic energy at 1 meter. We end up solving this, and for this you end up realizing that this whole idea of the kinetic energy is that the kinetic energy of the final, that's going to end up being the change in kinetic energy plus the original kinetic energy. which is going to be equal to, of course, well, we know that the change in kinetic energy is the work, right? So that's going to be 40 joules plus 1.5 5 kilograms, using the definition of kinetic energy being 1/2 mv squared, 1/2 m, and then 3 meters per second squared because it's given. And of course, using our handy dandy calculator and plugging in for the arithmetic, we can say that it is 62.5 joules. That is our final kinetic energy at the point of 5 meters.